Hello, welcome to the final part of AQA Physics. I'm going to answer the final question, longer answer. Right, okay, so let's get started. The student builds a different circuit. Remember the circuit from before was had similar lamps in it, but this is a completely different circuit, so don't worry about that one. Right, so let's label this. So I've got my pen, my on-screen pen to label this. So a nice colour. Right, so let's label this. So we've got a cell. Let's be a bit sick of writing. Right, a cell, an ammeter, an A for ammeter, nice and straightforward. This is a fixed resistor. Okay, this is a light-dependent resistor. Remember the light's going on it, so it's an LDR, light-dependent resistor. Okay, and this B for voltmeter. That's so straightforward. So I've labelled it. Go back to my writing colour. Okay, so explain how the readings on both meters, so the voltage and the current, so the ammeter and the voltmeter change when the environmental conditions change. Okay, so the LDR is obviously playing a huge part in this. So the resistance of the LDR changes in different light intensities. Light intensities. Okay, so when, let's describe it a bit more detail. When light intensity increases, okay, resistance of LDR decreases. The reason for that is it's something called a photoelectric effect. It's a bit like a solar panel when a light, so a solar photovoltaic, solar cell, when light shines on, electrons are released. It's the same type of thing. So if the resistance of the LDR decreases, the resistance of the circuit decreases too. So resistance of circuit decreases. So voltmeter doesn't change. But ammeter reading increases. Okay, so we're not measuring around the fixed resistor. Okay, but we could say that the potential difference, so P dot D, across fixed resistor sorry, increases. Well, I've been talking for a while, so I need a bit of a drink, I think. This day increases. Okay. Say that. So also we could say a bit of a comment on the general things. So potential difference, should write PD again, so I'm writing it all out. Potential difference is shared. Remember they're in series. There's an important point. Is shared between components in series. So often of course a load. So the smaller this is the reason for this one, the smaller the share of, sorry, the smaller, let's go for it, the smaller the, or the lower the resistance of the LDR, the smaller the share of PD okay. So say the voltmeter reading doesn't change, should sort of rectify this a bit more, so of whole circuit, but with the individual components it does. I'll explain it then. Voltmeter reading increases the whole circuit. PD across fixed, so you put the voltmeter across the fixed resistor. Yeah, it's not obvious with the question, this one at all. If you move, you can move the meters. The PD across fixed resistor increases because potential differences shared between components in series. So the smaller the resistance of the LDR, smaller the share of PD, okay, and the larger the share of other components. But the whole potential difference remains the same, okay, because it's being powered by a cell. So if light intensity increases, okay, so the PD or the voltage goes down across here and up across here, okay, but the whole thing, okay, remains the same. So the whole voltage remains the same across the whole circuit. Let's read out again. So overall resistance of the circuit decreases, potential difference across total resistance remains unchanged. That means the whole potential difference of the whole circuit remains unchanged. Current in ammeter increases because the resistance of the whole circuit went down. So the PD or the voltage across the fixed resistor, if you moved it, increases. Potential difference across LDR decreases. Okay, so the reading on the voltmeter decreases here. Okay, it's quite a complicated question. So, oops, not very straight line. This decreases. Okay, so because potential difference is shared between the components in series. So the lower the resistance of the LDR, the smaller the share of the potential difference, and the reading in the voltmeter decreases. Okay, so need to outline all of those things. Yeah, it's quite involved question. Okay, to get the 6 marks there, let's talk about the whole circuit and LDR, the ammeter, and the fixtures, all of the components. It wasn't obvious you had to mention all the components in that, but to get all 6 marks, you had to mention all the components there. Okay, so yeah, resistance on the LDR changes in different light intensities, 1 mark. When the light intensity increases, resistance of LDR decreases, the resistance of circuit decreases, 2 marks. I should say, just rectify this a bit, voltage, I should say voltage, so total voltage, a little bit, make it a bit clearer here. Total, realise, yeah, maybe people are confused. Total voltage of whole circuit doesn't change, but ammeter reading increases, fine. PD across fixed resistor increases, because potential difference is shared between components in series. The smaller the resistance of the LDR, the smaller the share of PD, and the larger the share of the components. And just the last bit. So voltmeter across LDR decreases. So that's the 6 marks there. So that's the end of the paper. So thank you for listening. That's probably the most difficult one of the paper. Everything else is pretty straightforward. Okay, so thank you for listening. Hope to see you in another video. Thank you and goodbye.